When you picture a glacier, what do you see? Probably this vast, pristine river of clean white ice, right? Something timeless. But here's the thing. As our planet warms, they're not just melting away. They're changing. They're transforming into something else entirely. What's left behind isn't just rock and water. It's this dynamic, evolving landscape that's telling us a whole new story about a glacier's afterlife. And the urgency here? It is real. Scientists are projecting that nearly half, 50%, of the world's glaciers will be gone by the end of this century. And the really sobering part? That's not the worst-case scenario. That's pretty much a done deal, already locked in by the warming we've already caused. So this is the big question we're really diving into today, because the word melting, it's just too simple. It doesn't capture what's actually happening. We're talking about a profound change in the landscape itself, a transformation into something new. So, what is the afterlife of a glacier? Okay, so to get our heads around this afterlife, we're going to start with a glacier that's basically in disguise, one that's hiding out in plain sight, right under a thick, rocky blanket. Meet the debris-covered glacier, or what scientists call a DCG. You see, as a glacier shrinks, the rock walls around it get exposed, and you get rock falls and all sorts of sediment piling up on the surface. Now this layer, it acts like a giant insulating blanket, which dramatically slows down the melting of the ice underneath, and totally changes the glacier's whole personality. And what's really wild is that these are not static landscapes at all. As the ice melts unevenly underneath that rocky blanket, the surface can sink by meters every single year. This creates these really beautiful but also incredibly treacherous lakes right on top of the glacier. And when the natural dams holding those lakes back suddenly fail, you can get these catastrophic glacial lake outburst floods, or GLOFs, that send a literal wall of water and debris hurtling down towards communities downstream. All right, now for phase 2 of this whole transformation. A landform that, honestly, looks more like a frozen landslide and has had scientists debating for decades. This is a rock glacier. And for a long, long time, scientists have been arguing about where these things come from. Is it just permafrost that's kind of seeped into a bunch of rock debris? Or is it something else entirely? The hidden, leftover core of a true glacier, just buried and moving in disguise. And you can totally see why there was a debate, right? They look and act so differently from their debris-covered cousins. They've got these distinct ridges that run across their surface, almost like giant frozen ripples. They move unbelievably slowly. We're talking just centimeters per year. And you almost never see surface lakes or any exposed ice. It's a much more stable, solid-looking landform. And this comparison just makes the differences crystal clear. You've got fast, kind of chaotic movement on the debris-covered glacier versus this super slow, coherent flow on the rock glacier. You've got lakes all over the place versus almost none. So for ages, this led scientists to put them in two totally separate boxes, thinking they were formed by completely different processes. But what if they're not? This is where the whole mystery starts to unravel. It's the aha moment that connects these two seemingly separate things into one single, incredible story of transformation. So this is the big idea, the Great Glacial Continuum. Instead of thinking of them as separate things, we're actually looking at stages in a life cycle. It starts as a clean glacier. It gets covered in debris, becoming a debris-covered glacier. Then, over time, as the active ice underneath stagnates and shrinks away, the whole landform slowly transitions. Its movement slows way down, its surface stabilizes, and eventually it becomes a rock glacier, the final, slow-moving ghost of its former self. And check this out. This isn't just some abstract theory. Scientists are literally watching these transformations happen in real time. On Pakistan's massive Siachen Glacier, they've seen this process unfold over just 50 years. In Chile, about 60. And some models are even suggesting that with continued warming, this entire transformation from one to the other could happen in as little as a century. So if this is happening all over the world's high mountains, how on earth do scientists actually track and map such a slow, massive process across this incredibly rugged and remote terrain? Well, it's a huge challenge. As this research points out, a lot of the early mapping attempts were kind of thrown off by really simple obstacles. A cloudy day, deep valley shadows, or even just a heavy snowfall could make it almost impossible to tell a debris-covered glacier apart from a rock glacier when you're looking from space. But today, scientists are tackling this with a seriously high-tech toolkit. They're layering all these different types of data, You've got optical images to see the surface, thermal data to detect the cold of the hidden ice, and advanced radar to measure these tiny shifts in texture and movement. Then they feed all of that into a powerful machine learning model, which can spot patterns and tell these landforms apart with an accuracy way beyond what the human eye could ever do. Okay, so let's zoom back out and connect this all to the big picture. Why should we care so much about telling the difference between what might just look like one pile of rocks and another slightly different pile of rocks? Well, it turns out this is so much more than just an academic exercise. The hidden ice that's locked away inside these landforms, that is a critical source of fresh water, especially late in the dry season when other sources run out. Understanding this whole continuum lets us better manage those water resources, predict catastrophic flood risks, and really get a handle on how our most sensitive environments are responding to a warming world. You know, this whole story of the glacier's afterlife is such a powerful reminder that the consequences of climate change aren't always sudden and dramatic. Sometimes they are these slow, complex transformations, hiding in plain sight.